Good evening. Welcome to Cornerstone Home Inspector Education Center. Tonight we have Stan Bajerski, one of our owners, going to be presenting inspecting 100 to 300-year-old homes. A couple of notes, we have a lot of material to get through tonight. If you have any questions, just use your chat box, and I'll be happy to take care of those during the webinar. And also, when this becomes in the so we have a bunch of pre-recorded events, webinars on our website. If you decide to watch any of those now, our certificate page is now password protected. So don't panic. After you're done watching your video, if you don't have the password, just email us, comes into me, and I send you the passcode right away. So this way you can submit for your certificate. Again, if you have any questions, just use your chat bot and we'll hand it over to Stan.
Hey, good evening, everybody, and welcome. Tonight we're going to talk, as Jim said, about inspecting 100 to 300-year-old homes. It's interesting over the years how people tend to panic and stumble when they're going into one of these older homes. But you know they're the same as any other home, and you should be approaching them pretty much the same way. But you do need some information in mind because they are built a little different. Why is that not scrolling?
So use your down.
Okay,
There you go.
got it. So if you look, we kind of condensed all of the states that we cover, their standards of practice regarding structural. So we are required to perform a non-invasive visual examination of a home's readily accessible systems and components, regardless of the property's age, including homes 1 to 300 years old, following limitations and exclusions of their representative state standards of practice. Inspectors must observe and report on the condition of the structure, exterior roofing, plumbing, electrical, heating, cooling, interior, all the components of the home. That's not going to be any different whether it's a 2026 house or an 1826 house. What you're going to see may be different, right? But rot is rot. You're not going to see a 200-year-old heating system in a 200-year-old house. Probably not. You might see an older roof if it's slate, but you're going to approach it the same way, no matter what age of the house. Are you used to this? Okay. So what this webinar covers. So we're going to talk about historic construction because it's a little bit different than what we're seeing today. Common defects, which would be probably in older homes. You know, you could still have structural issues in newer homes. They're going to be a little different, or the reason will be a little different for the most part. Safety hazards that may be existing in older homes that you may not typically see in newer homes, and inspection limitations. And as we speak in every webinar, they really need to be recorded and defined for liability purposes. So, and then special referrals. We got a couple pictures later on where there are specialists in restoring older homes if you want to go that far and you identify a problem in a post and beam construction. I don't think the average carpenter will go in there and make repairs the way they should be made. So there are specialists in certain types of framing. For the purpose of this course, we're examining residential structures built between 1700 and 1920, a span covering over 2 centuries of American construction evolution. This period encompasses colonial homes with their simple, symmetrical design, Federal era structures featuring refined proportions and decorative details, ornate Victorian homes with complex roof systems and decorative trim, and early craftsmanship designs emphasizing natural materials and handcrafted elements. Each architectural era brought distinct construction methods, material choices, and design philosophies. Understanding these characteristics help inspectors anticipate common defects and recognize whether later modifications may have compromised the original structural integrity. The transition from hand-hewn timber framing to balloon framing, from stone foundations to early concrete, and from other individual craftsmanship to standardized lumber, all occurring during this transformative period. So there are some challenges with historic homes. You need to know a little bit about how homes were built hundreds of years ago. Older homes present unique obstacles that require adjusted inspection technique and realistic client expectations. Hidden defects concealed behind original plaster siding or finishes, that's in any home. Limited accessibility due to low crawl spaces, narrow attics, and steep stairs. Outdated electrical, plumbing, and heating systems that don't meet modern codes. Materials no longer manufactured or commonly used, making condition assessment challenging. Safety concerns for inspectors navigating fragile floors, exposed wiring, and confined spaces. Early American homes relied on post and beam construction, where heavy timbers formed the structural skeleton. Craftsmen hand-hewn these beams using axes, creating distinctive irregular surfaces with visible tool marks. Mortise and tendon joints secured with wooden pegs, connected these massive timbers without metal fasteners. Each home was essentially custom built with dimensions determined by available timber rather than standardized measurements. As sawmills became more prevalent in the early 1800s, dimensional lumber replaced hand-hewn beams. This transition enabled more consistent sizing, but often resulted in smaller structural members. Early masonry work utilized fieldstone or locally made brick set in lime mortar, softer and more flexible than modern Portland cement. By the middle 1800s, balloon framing revolutionized construction using lighter, closely spaced studs that extended continuously from the foundation to the roof, making 2- and 3-story homes easier and faster to build. If you are watching this as a pre-recorded webinar, record this viewing code HH7837. There will be one more. Send them both to us in order to get your certificate. So the older homes, besides defects and lack of maintenance, there is some aging process with any material, but because the older homes are older and the materials are older, are different, these are some of the things that we really need to be looking at. Wood movement, we have a whole webinar on the properties of wood and how temperature and moisture affect wood movement. Centuries of seasoned moisture change cause lumber to shrink, warp, and develop splits. Original tight joints loosen. The structural members may twist or bow. This movement is cumulative and irreversible. Foundation settlement, stone and early brick foundations settled unevenly over time. Differential movement creates stress throughout the structure, visible as cracking in walls, sloping floors, and doors that no longer close properly. Cut nails and early wire nails corroded, losing holding power. Wooden pegs dry out and shrink. This gradually weakening allows structural members to separate or shift, particularly at connection points. And then biological damage, rot, moisture damage, insect activity compound over centuries. Wood-boring beetles, carpenter ants, and termites may have been active intermittently for generations, leaving hollow structural members behind. All these things affect the structure in different ways. Early foundations typically consisted of fieldstone. These are rounded stones gathered from the land and stacked with minimal mortar. These foundations lacked the uniform courses and tight joints of modern masonry. The lime-based mortar used historically is softer than the stone itself, designed to absorb movement and moisture. And over time, this mortar erodes, leaving voids between the stone that allow water infiltration and reduce structural integrity. And there are just stacked stone foundations that don't have any mortar. Common defects, including bulging or bowing walls, probably seen bowing walls a lot, where hydrostatic pressure or deteriorated mortar has allowed movement. Water intrusion patterns are distinctive. White efflorescence indicates mineral deposits from moisture migration, while dark staining suggests active water entry. Missing or deteriorated mortar joints create pathways for rodents and insects. Most historic foundations lack modern footings. Stones often rest directly on compacted soil, making them susceptible to frost heaving and settlement. Brick foundations from the late 1800s face similar challenges with added concerns about soft underfired brick that crumbles when exposed to freeze-thaw cycles. Jim, is this a video?
Yes, you want to scroll down and right to your bottom left. There you go. Play that.
So this is a video Jim took recently.
House, Middletown, Connecticut. Stone foundation. Sort of updated electrical. Water shutoff, modern piping, center chimney, significant cracking. Stone floor, crushed stone. Plastic vapor barrier. Heating, water heater. Plumbing updates.
So this is really classic, right? The floor underneath that crushed stone is probably dirt. The water heater is almost as tall as the crawl space there. And, you know, that might have been a crawl space, less headroom that was dug out over the years to be able to put these modern appliances and plumbing and electrical in. This house probably didn't have any or lesser versions of those things. So this is the evolution of these older houses. So your field stone foundation's it's mortared up on the left and either lost its mortar or just a rubble build on the right. And looks like a brick or big blocks there. If you notice that the foundation is not straight, we got a few more pictures of this, and the sill is following the foundation. You see a little sag in the middle. That's where these houses start to lose their squareness, but gain their charm, right? Because a lot of people look for houses like this because they have wavy floors and all the telltale signs of a structure built back then. Here's another video, 1795.
Glastonbury, Connecticut. Stone foundation, severely bowed out. You see the windows are slanted. Not good.
I can step in for 1 second on that. Is an engineer passed that foundation. So I was going when I took that video and I wrote it up in the report, I sent it to everybody. I asked for, evaluation by a licensed engineer. I didn't even deal with a contractor. I wanted to make sure it was fine. They came out and they said it was fine, no problems. So go ahead, Stan.
So crawl spaces, they're in all different age houses. This one has been retrofitted. So historic crawl spaces often measure less than 18 inches in height, making thorough inspection difficult or impossible. Many were never designed for access. They're simply the space created by a home sitting on short foundation walls. Inspectors must clearly document accessibility limitations in their report, as with any other house. These shallow spaces typically have dirt floors, minimal ventilation, creating persistently moist environments. Long-term moisture exposure causes extensive rot in sills, floor joists, and subfloors. Wood in contact with the stone foundations wicks moisture continuously. Evidence of chronic dampness includes white fungal growth, wood that crumbles when probed, musty odors. Ventilation problems compound moisture issues. Historic homes rarely have adequate foundation vents, and vegetation often blocks existing openings. Modern vapor barriers are typically absent, allowing ground moisture to migrate upwards into wood framing. I'm going to say that most of the houses that I have done over 4 decades have been upgraded to a certain degree. And eliminate a lot of these issues over time. Floor framing, common defects. Overspan joists or undersized joists, however you want to look at it. Original floor joists often span greater distances than modern building codes allow. Hand-hewn timbers were sized based on available trees rather than engineering calculations. Even with larger dimensions, excessive spans lead to deflection, bouncy floors, and visible sagging. Inspectors should note excessive span conditions, and resulting floor movement. But you know, to me, I wouldn't make a big issue out of it if that's the way the house is built. There are ways to take those things out, and you reframe or resupport. But that is the normal characteristic of an older home like that. Notching and cutting. This is pretty significant. Decades of renovations leave floor joist knots for plumbing, electrical, and heating installations. Previous contractors often cut indiscriminately through structural members to route utilities. Deep notches near joist ends or holes through the middle third of the span significantly reduce load carrying capacity and may cause structural failure. Uneven floors result from foundation settlement, undersized joist, and structural modifications. Slopes exceeding 1 inch in 20 feet suggest significant structural movement. However, some slope in historic homes represent centuries of gradual setting that have stabilized. The key is distinguishing between old stable movement and active progressive problems. Powder post beetle, carpenter ants, termites leave distinctive damage patterns. Fresh sawdust indicate active infestation. Small exit holes surrounding powder suggest beetles. Hollow sounding wood when tapped may indicate extensive hidden damage. Probing suspected areas with an awl reveals compromised wood that crumbles easily under pressure.
That's a video.
Yep, got it.
Powder post beetle damage on the sill, not uncommon for a house from 1700.
So don't forget, even though that doesn't look significant, it does weaken the integrity of the wood, probably cause it to sag, and definitely, you really have to look at the whole structure to determine if it really needs some work or not. So here's some pictures of overspan joists. These guys are just sitting right in the foundation with the wall on top of them there. And it's hard to tell, but these are 8s, 6s, who knows? These look like maybe 6s. They're notched. Some drop in the flooring, which is kind of typical. And to correct this is a big project. If you're gutting the house and remodeling it, that's easier to do than to try and fix this without getting too deep into the renovations. Here's more powder post beetle. If you hammered a piece of wood with powder post beetle, it's gonna just turn into dust. It kind of holds it together, but if you strike it, dust will come pouring out of these holes. So balloon framing, I'm hoping everybody knows about balloon framing. Introduced in the 1830s and popular through the early 1900s, revolutionized residential construction. This method uses continuous wall studs extending from the foundation sill plate to the roof, with floor joists attached to the sides of the studs rather than resting on top of wall plates. This creates open vertical cavities running the full height of the building, essentially unobstructed chimneys within the walls. The primary concern with balloon framing is fire spreading. Flames entering a wall cavity at the basement level can quickly travel up to the attic and roof, bypassing each floor. Modern platform framing naturally creates fire stops at each floor level, but balloon framing walls lack these barriers unless specifically retrofitted. During your inspection, look for evidence of fire blocking. Horizontal members installed between studs to compartmentalize vertical cavities. Many balloon frame homes have never been retrofitted with proper blocking. Recommended evaluation by a qualified contractor when balloon framing is identified. particularly if electrical or plumbing penetrations have created additional pathways between floors. Document this as a safety concern. We have pictures
That's
later
also,
on.
that's a video.
Glastonbury, Connecticut, 1795, home on Main Street. We're in the attic. You can see what type of framing. You see the attic has no railings. The stairs have no railing. Our original wood decking, some upgrades, and more framing. And then we get to the masterpiece, which is the center chimney. No flues in that chimney. 5, 6 fireplaces. Pretty special property.
Still there too, right? After all those years.
Yep.
So here is your picture of your balloon framing. So wall studs rest directly on a double sill plate and are face nailed to joist and toenail to sills. And that space in here, if not blocked, creates a chase all the way up to the attic, and that fire will spread through that house so fast it's not even funny. So you really need to do your due diligence when you're in the basement, because you may see some of these blocked. There may be some open. So I try to go through all of them. Some of them might have been knocked out to run electrical or plumbing over the years. So kind of keep your eyes open, check as much as you can. And even if you don't see any open, I would have a standard phrase saying if you come across an open stud bay, it needs to be fire blocked for safety purposes. So these pictures are from, I have a friend who has a historic home in Milford, and he was doing the renovations in this home with a bunch of guys that specialize in mortise and tenon and all that good stuff. This is some things that you would not see when the house is completely sided. This is the outside of the house, and the sill damage. This was all rot that nobody knew about until you took the siding off. More of this, a similar situation here, big hole here. So everything's going to naturally kind of sink into the weak spots of these damaged sills. Nothing here in this corner when they took the material off. And if you look at this sill here, this piece of wood must have been used in another house, and they brought it here. The foundation is not level. That's just the way it was. And the wood eventually just follows the shape of the foundation, and that transmits through a lot of the house. That's why these houses typically have the slope, the pitch, the yaw. That's that corner that had nothing when they stripped it. This is the bracing originally of the house and the corners. They put these studs in themselves. This corner right here. And these guys are using old tools to refurbish this house. So it was pretty cool. But this is stuff you're not going to be able to see that may exist in older homes that would translate into a sloping, sagging, bowing walls, floors, and roofing. More of the repair. But I just thought it would be good to see. These guys cut all these mortise and tenon right on the property here. So roof systems in historic homes. Early roofs used wood shakes or slate tiles that can last over a century with proper maintenance. However, individual pieces become brittle and crack. Missing or damaged shakes allow water entry. Slate roofs may have failed fasteners, causing tiles to slip. Both materials are heavy, requiring substantial roof framing. Original flashing materials, often lead, copper, or tin, deteriorated or were improperly installed during later roofing replacements. Counter flashing and chimneys frequently separated from masonry. Valley flashing corrodes through. Step flashing along sidewalls may be missing entirely, especially after multiple re-roofing projects that layered new materials overall. Um, Roof framing often shows visible sagging, particularly at midspan. Rafters may be undersized for the span or spaced too far apart by modern standards. Ridge beams sag under accumulated weight. Collar ties may be missing or have pulled loose. While many sagging roofs have stabilized and remain functional, document the condition and extent of the deflection. I will tell you also what I see a lot, and it doesn't have to be a 200-year-old home either, but a lot of these older homes originally had wood shingles over what I refer to as skip sheathing, right? So when you're in the attic, you can see half of the roof shingles resting the top and the bottom on um, slats of wood, and then 2 layers of asphalt on top of those. And the roof nails have to be very long, and you will see the roof nails coming. A lot of municipalities consider the wood roof sheathing, but they don't typically hold the nails in very well. And eventually those shingles are going to pop, they're going to lift, and they're more susceptible to blowing off during high winds. So I always bring that to the attention of my clients if I see asphalt over wood shingles with no plywood applied. Um, Obviously, there wouldn't be plywood because the wood shingles are still on there. So I tell them, be prepared. You have damage and you're gonna lose shingles. And the next time around, you got to get plywood down now. So it's going to be an expensive job. Slate roof inspection considerations. I don't think I did more than 5 slate roofs in 38 years, but slate can last 75 to 150 years depending on slate quality and installation. However, not all slate is equal. Lower grade slate begins to delaminate after 50 to 80, while high grade slate from Vermont and Pennsylvania remains sound for over a century. Sound slate rings clearly when tapped, generally gently with a knuckle, like tapping glass. Deteriorating slate produces a dull thud and often shows flaking or delamination where layers separate. Missing slate valleys with makeshift repairs and flashing failure are common. Most slate failures result from deteriorated fasteners rather than the slate itself. Copper nails corrode, causing slate to slip. So when you roll up on a slate roof house and you see loose slate, cockeyed, I don't care if you see a dozen or just 6, there are going to be more. That's a major issue. Matching slate is difficult and expensive. New slate must match thickness, color, and size of existing materials. Partial roof replacement rarely succeeds because new and old slate weather differently, creating patchwork appearance. Often the entire roof requires replacement when deterioration begins, representing a significant expense clients should anticipate. So you at least need to bring that to their attention. So siding on these houses. Historic siding typically consists of wood clapboards, cedar shakes, or early wood shingles. These materials require regular maintenance, painting or staining every 5 to 10 years, which is often deferred. Inspect closely for wood rot, particularly at horizontal surfaces where water collects, wood sills, bottom edges of siding, corner beads. Press suspected areas with a screwdriver or awl to identify soft deteriorated wood. Lead paint is virtually guaranteed on homes built before 1978 and extremely common on these earlier structures. So peeling or flaking paint poses health hazards, especially for children. Document lead paint concerns, but avoid making definitive statements about lead content without testing. Recommend evaluation by a certified lead inspector when extensive paint failure is present. I do that for every house built prior to 1978, even if it's a flip that was done a year ago, because we don't know exactly what was done in that house. So same thing should go for these guys. Sill rot is endemic in historic homes, as you saw in those pictures. The sill plate, the horizontal timber resting on the foundation, is vulnerable to moisture wicking from the masonry and splashback from inadequate roof drainage. Severely rotted sills compromise structural integrity and require extensive repairs. Improper past repairs are common. Mismatched materials, vinyl or aluminum siding installed over rotted wood, and spray foam applied to conceal rather than correct moisture problems. So you got to be on your toes because these houses get a lot of attention over the years that they've been on this earth and not always the right repairs. Chimneys are a big issue because a lot of them are not lined. And if I'm not saying it's okay if it's just a heating system and a water heater, but with fireplaces, it becomes more of an issue. Masonry chimneys in older homes face multiple deterioration mechanisms. Soft, underfired brick from the 1800s and early 1900s crumble when exposed to the weather, particularly freeze-thaw cycles. So you're looking for spalling brick faces where the outer surfaces have delaminated and fallen away, and for deteriorated mortar joints between courses. Missing or deteriorated chimney liners are especially concerning. Many historic chimneys lack any liner. They're simply brick stacked around a flue opening. Unlined chimneys allow heat and combustion gases to contact brick and mortar directly, causing accelerated deterioration. Creosote deposits accumulate on rough, unlined surfaces and pose fire risks. Cracked or missing terracotta liners fail to contain heat and gases adequately. And don't forget, no liner, you can't see half of that chimney where it passes through the living space of the house. And if the mortar joints are open, then we possibly can have smoke, carbon monoxide backing up into the house. Leaning or separated chimneys indicate foundation problems or inadequate attachment to the main structure. Chimneys built on separate footings settle independently from the house, creating gaps where once there were none. Inspect the attic carefully where the chimney penetrates the roof. Look for daylight, water staining, and gaps between chimney and framing. Recommend evaluation by a qualified mason for any chimney showing significant deterioration, separation, or leaning. How many of you have seen the chimney come through an older house and then they corbel it to the left or the right because they don't want to go right through the ridge of the roof? A lot of times they're still braced, but that's another common thing that you'll see. And if it's the first time you're seeing it, you may scratch your head a little bit. It's generally not a structural issue, but don't forget, the inside of that chimney is going to look like a stairway, and water is going to sit on there, and you're probably going to see a lot of mortar deterioration in those areas as well. Hey, Jim?
Yeah.
My screen is frozen.
Use your on your keyboard. Use your down arrow. That'll switch it too.
It's frozen.
Oh.
It's not doing it.
Okay. Hold on.
Oh, there we go.
There you go. Okay.
All right, hold on. So there's one. Windows and doors, original challenges. So the weight and pulley system. Original double hung windows use ropes or chains connected to cast iron weights hidden in the wall pockets. These systems often fail when the ropes deteriorate, causing upper sashes to fall unexpectedly, which would be a safety hazard. Replacement ropes require accessing weight pockets, which may be painted or wallpapered shut. So it is a big job. You pull the window stops off, you put new rope in there or the chain, reconnect the counterweight. Single pane glass. Historic windows have single pane glass, providing minimal insulation. Clients should expect higher heating and cooling costs unless windows have been upgraded. Storm windows improve energy performance but add maintenance requirements. Document window condition and note single pane construction as a maintenance and efficiency issue. Window sills and exterior casings deteriorate from water exposure. Improper flashing or missing drip caps allow water behind the trim. Interior sills show damage from condensation. Probe wood components at all windows, particularly bottom rails and sills. Widespread rot requires extensive repairs and may indicate whole house moisture problems. Basement and attic stairway doors often swing outward over the top step. a dangerous configuration. Low head clearance at stairways create injury risks. Missing or inadequate handrails fail to meet safety standards. While historic homes aren't required to meet current codes, document these conditions as safety concerns for prospective buyers. So here is the counterweight. There's going to be one for each sash, the rope connected to the sash. And if everything's working fine, they balance each other out. So you push the sash up, it stays where it's supposed to be. Once these things break, sometimes if there's enough paint on the windows, the sashes will still stay in place. But obviously, that's not the right way to go about it. So when I'm doing a home with these guys in there, you could see if the windows are closed that there'll be no rope, no chain, or part of the broken rope. So keep your eyes open, take a look at them. This is typically, if you can even operate them, because a lot of times, upper sashes are painted shut. But you want to spend a little time on the windows in an older home. Window glazing and muttons. Historic windows offer unique characteristics that often can't be replicated by modern replacement. Understanding these elements is key to proper preservation and maintenance. A lot of people that are specifically looking for a vintage home want the windows to be as they were. So there are people out there that will restore them. It's very expensive. So wavy glass, a mark of authenticity. Single pane glass from the 1700s to the 1900s often exhibit waviness and imperfections like bubbles, ripples, and slight thickness variations, all stemming from hand manufacturing processes. This unique aesthetic is valued by preservationists, though it provides minimal thermal performance. In true divided light windows, the muttons are the structural wooden dividers that create the individual frames for each glass pane. In contrast, modern simulated divided light windows use a single large pane of glass with decorative grids applied to the surface, and imitation that lacks the authenticity and structural integrity of the historic home originals. Beyond these visual characteristics, original glazing compounds harden and crack over time, leading to water infiltration and glass movement. Addressing failed glazing is a crucial maintenance task. While reglazing is straightforward, it is labor intense. And you got to do it a couple times to get it right. It is a little bit difficult. In cases of extensive rot and sashes and muntins, professional evaluation by a window restoration specialist is recommended, as restoration can often be more cost-effective than custom replacements designed to match historic profiles. I will tell you that in the older houses that I have done, maybe only 2 of the prospective buyers were intentionally looking for a vintage home. The other people were just kind of getting their toes wet with it. And, as long as they take all this information and understand what we're saying, they can make an informed decision. So here's another very important component that still remains in a lot of these older homes. So the electrical system can be outdated and unsafe. Knob and tube wiring, I think we've all probably seen some portion of a knob and tube in older homes. It's common from the 1880s to the 1930s. Knob and tube wiring consists of individual conductors running through ceramic insulators attached to the building's framing. While it can remain functional if undisturbed, it's inadequate for modern electrical loads and often improperly modified. As systems get upgraded, these circuits, a lot of them will run through the walls, and people don't want to rip the walls apart to take all the knob and tube out or replace it with at one time BX and now Romex. So a lot of times you'll see them running into a junction box and they're still powered. It's been my experience that a lot of them are on exterior walls, the outlets, and a lot of attic lighting is still a knob and tube wiring. So we had this discussion, I think, was it last week when we did GFIs? You can, I just want to clarify, we were a little unclear hazy last year. You can use a GFI to protect a existing knob and tube circuit. You're not going to correct the ground, but you're going to protect the equipment that may be on it or the person using that outlet. So if you come across a GFI in the middle of a room and it's nowhere near any kind of water source and it's in an older home, it might be an ungrounded knob and tube circuit. So grounding and installation in this system it lacks an equipment grounding conductor, a critical safety feature in modern electrical systems. Additionally, it relies on antiquated insulation materials that become brittle and crack over time, leading to exposed conductors and increased risk. So I always tell people to replace the knob and tube wiring. They can do what they want afterwards, but I will cover my rear end in the report by telling them they need to do whatever they need to do to get that out of their house. Beyond knob and tube, other concerns include cloth wiring from the 1920s to the 1950s, where fabric insulation can deteriorate, exposing conductors and creating shock and fire hazards. Fuse boxes, though functional, limit total electrical capacity and lack circuit breaker protection of modern panels. Ungrounded circuits often indicated by two-prong outlets, unless specifically tested, also present significant safety risks. Insurance companies frequently refuse coverage or charge higher premiums when these older systems are present. Unsafe splices are endemic in attics and basements of historic homes. Look for connections made with electrical tape rather than proper junction boxes. Wire twist together without wire nuts, and connectors spliced inside walls or ceiling cavities where they're inaccessible. Recommend evaluation by a licensed electrician for all knob and tube, cloth wiring, and ungrounded systems. Plumbing systems. So when this is one thing that I would always tell my interns to be careful with. Chimney, of course, and take a look at that sewer line as it's leaving the house. Is it still cast iron? Could be the original. And of course, we're going to recommend a scope. But plumbing materials from the 1700s through the 1950s have limited service lives. Most systems in truly historic homes have been partially or fully replaced, but original piping often remains concealed in walls or foundations. Lead supply lines from the main to the home and from well pumps create health hazards. Lead service lines are dull gray, soft enough to scratch with a key, and were standard through the 1950s. I still find them occasionally. Galvanized steel piping corrodes from the inside out, reducing water pressure and flow. Expect a 40 to 50-year service life. Rusty water and low pressure indicate advanced corrosion requiring replacement. Of course, it's still out there. And I also recommend that all galvanized piping be replaced for the same reason, to cover my butt and to help them make sure they don't have any problems. Cast iron waste lines rust through, particularly at horizontal runs in concrete and at joints. Corrosion creates rough interior surfaces that catch waste, leading to chronic clogs and eventual failure. So if you're inspecting any cast iron pipe, you look at the bottom especially. Find these little stalagmites and little buds that are a little wet. The pipe has a problem. Early copper within walls develop pinhole leaks, evidence of past leaks behind plaster walls, water stains, efflorescence, and patched areas suggest ongoing problems. Heating systems, boilers, radiators, chimneys. Many historic homes retain original or early vintage heating systems. So cast iron radiators supplied by basement boilers, gravity furnaces, or coal-converted oil to gas systems. While these systems can function for decades with proper maintenance, they present several concerns for home inspectors. Steam and hot water boiler systems require intact piping, properly functioning pressure relief valves, and adequate combustion air. Check for evidence of leaks at radiator valves and pipe joints, white mineral deposit and rust stains indicating chronic weeping. Test radiators for heat during operation, noting any that remain cold, which suggest valve failures or air blocks. Older boilers may lack modern safety controls. like automatic gas shutoffs and flame sensors. Combustion safety is critical. Many older boilers vented to chimneys shared with fireplaces or wood stoves. See that frequently. These chimneys may lack appropriate liners for specific fuel being burned. Abandoned flues, where heating systems have been replaced but old vent connections remain, create draft problems with potential carbon monoxide hazards. Always check for proper draft, intact venting, and adequate clearances combustibles the best you can. Recommend evaluation by a licensed HVAC technician when safety concerns arise or equipment appears original to the home built before 1970. So steam heat, one pipe or two pipe steam system with cast iron radiators. Boilers generate steam that rise through pipes to radiators, condenses and returns. Steam systems operate near boiling temperature and must have functioning pressure relief valves. Check for leaking valves, missing radiator air vents, and banging pipes indicating improper pitch. Hot water system, similar to steam but uses circulating hot water at lower temperatures, requires circulator pumps, expansion tanks, just like a modern heating, hot water heating system. They are more efficient and comfortable. Gravity furnaces, can't remember the last time I seen one of those, but I've seen a few. I don't even know why they would be in a house. They can't really heat very efficiently, but if you see one, I would recommend that the house be retrofitted with something more modern. And then heating a house today with coal, I think is probably antiquated. And I don't think you're going to see that too much. Interior walls and ceilings, lath and plaster. Historic walls and ceilings use wooden lath. Thin strips nailed to studs, covered with multiple plaster coats. You know, the biggest issue here, they could contain asbestos fibers, and if you see cracking and it's loose, obviously that needs to be taken care of right away. But you may find some cracks that are tight. I still think that's something worth mentioning. The cracking and delamination, you know, bulges, things of that nature. It's just broken away from the wall. I was doing an inspection. There was like 5 or 6 of us walking through the house. We were going from the second floor to the attic. We were all on the stairway. And it must have been bouncing like heck. And a large portion of the plaster wall just fell off into the hallway. So it did. You didn't see it when you walked by, but it was so loose that so much traffic on the stairway, it just fell off. Missing insulation. Unless retrofitted, most of these homes did not start with any insulation. So I would kind of get a handle on where there may be some, and always talk about trying to get as much insulation in the house as you can. Opening historic walls releases decades of accumulated dust containing lead paint particles, asbestos fibers from joint compound, and other contaminants. Warn clients that renovations require proper containment and disposal procedures, significantly increasing cost of renovation. Floors and stairs, probably will see a little different type of flooring, although we are simulating a lot of the old flooring now. Wider plank type, pine or oak, 12 to 16 inches. They shrink and expand dramatically with seasonal moisture, creating gaps in winter and cupping in summer. Gaps exceeding 1/4 inch allow drafts and pest entry. Widespread cupping indicates moisture problems in crawl spaces and basements. So the theme is moisture in these older houses, although that's something that we're going to be looking for no matter what house we are inspecting or the age. But it's a little more critical in these older houses because they're so loose. Some floor noise is normal in older homes caused by dried out wood moving against nails and adjacent boards. Severe squeaking accompanied by deflection suggests loose subfloors, deteriorated joist, or interior inadequate joist support. Inspect below these squeaky areas if you can to identify structural causes versus cosmetic annoyances. Uneven stair treads are very common and could be a tripping hazard. Loose railings, any house, or no railings. So code limitations predate modern building codes in these historic homes, and steep stairs, inadequate headroom, missing handrails. Other deficiencies are grandfathered unless substantial renovation trigger code compliant requirements. Document conditions clearly, but acknowledge existing nonconformities. Attic inspection. Most of the time, you're going to get up into the attic. They reveal accumulated evidence of past problems and ongoing deficiencies. Old electrical wiring, particularly knob and tube, is often buried under insulation, added during energy efficiency upgrades. This creates fire hazards because insulation prevents heat dissipation from energized conductors. Document any insulation covering knob and tube wiring and recommend removal or rewiring. Moisture staining on roof sheathing and rafters indicates past or present leakage. Dark streaks along rafter sides suggest condensation problems from inadequate ventilation. Attic leaks show wet sheathing, or active leaks show wet sheathing, standing water on attic floors, or dripping from penetrations. Trace staining back to its source. Roof covering failures, flashing problems, or plumbing leaks from bathrooms below. Historic attics typically lack soffit and ridge vents, which weren't standard until the mid-1900s. Poor ventilation causes heat buildup in the summer and moisture accumulation in the winter. Gable vents alone provide inadequate airflow. Modern baffles at rafter bays are usually absent, allowing insulation to block small air flows that exist. Rodent damage is common. Look for chewed insulation, droppings, and nesting materials. Extensive rodent activity suggests entry points at eaves, gable ends, or where utilities penetrate walls. You know, we go through this on every webinar, and I'm just going to go through these 4 procedures again. So you record your observations, explain why it matters and what the consequences are. Recommend, if you feel you have to, the appropriate next step. And if you feel you need to recommend evaluation or repair by a qualified masonry contractor, that's perfectly within that recommendation. And again, and I can't say this enough, clearly state what could not be inspected and why. Floor framing beneath finished basement ceiling was not accessible. Recommend evaluation if ceiling is open during renovation. Those are very important things. Document limitations clearly, as we said. Use cautious language. Emphasize the safety concerns of a house of this age. And I think we all prioritize safety hazards in the report, no matter what age the house is, whether it's a condo or safety comes first, as far as I am concerned. When to recommend specialists. I think we're all probably have some ability to make recommendations on some repairs. I don't think you need a specialist if the stairway railing is loose to recommend somebody to tell you how to tighten your stairway railing. But, you know, electricians, masonry contractors, stuff like that, if you feel the repair is extensive enough, then you want them to get somebody that knows what they're doing, that do it day in, day out. And then the historic preservation specialist, they're out there if they want to really restore their home and make it look like it did when it was first built. Those are the go-to guys. A lot of times clients will ask, is the home safe to live in? If we're looking at an 1700 and 1750 house and it's still there, and you're in it and walking through it and you haven't fallen through the floors, it probably is. You're going to tell them the safety issues that might be related to this home. They may ask you how much will repairs cost. I used to know pretty much what it cost to do certain things, but after COVID, I have no idea what materials cost. So I think that's best left to people in the trades to talk about repairs and cost. How long until a system needs to be replaced? Well, we do that every day, right? No matter how old a house is, we have rough ideas on the useful life of pieces of equipment. And I think that most of us incorporate that in our report anyways. And then should I buy this house? Well, I've always escaped that. And I got a couple ways to do that, but we got what's much more material. So we're going to move forward. I don't think we need to spend a lot of time on this because building codes didn't exist when a lot of these houses were built, even houses built into the 1900s. So, and you know, my house was built in 1940. It's getting close to 100 years old already, believe it or not. So building codes establish minimum standards for construction safety and performance, but they're not retroactive. Existing structures aren't required to meet code adapted after their construction. This grandfathering means historic homes legally contain numerous conditions that wouldn't be permitted in new construction, but are grandfathered in because of when they were built. Code compliance became required only when substantial renovations trigger modern standards, renovating a kitchen, putting on an addition, things of that nature. The definition of substantial varies by jurisdiction, typically 50% or more of a system or structure. Installing a new electrical panel might require bringing all wiring to current code. Replacing more than half of a roof covering could mandate adding insulation and ventilation meeting current standards. As an inspector, distinguish between code violations in recent work and pre-existing non-conforming conditions. Recent unpermitted additions or DIY electrical work that violates current codes deserve emphasis. It may be done incorrectly regardless of code adoption date. Original conditions that predate code should be identified as safety concerns or maintenance items without implying code violations. Your report isn't a code compliant audit. It is an assessment of conditions and functional. Focus on safety and operability rather than strict code conformance in homes built before modern standards existed. That's kind of important. Your second viewing code is CH8362. Submit the two codes to us to get your certificate.
Yeah. That's if you're watching it as a prior event. You do not have to submit for tonight because you're watching it live.
Photographing. I would suggest that you use your photographs as if you would in any other home. There's no reason to change. You may want to take a little more because it is an older house, or if you find significant defects, but there's no reason to change how you do your inspection regarding your photos just because the house is older. I think for the most part, it's easy to determine when a novice or homeowner has made a repair. If it just doesn't look right to you, but you know, they may have hired somebody that's just as bad. Don't get me wrong, but anything that does not look good or right to you, whether you're not sure 100%, don't be afraid to say that. Just tell them that it should be evaluated by a qualified licensed plumber or electrician. Don't step out on a limb, but don't cut yourself short. Protect yourself from liability. Call it out. Some of it there might be. Was that you, Jim?
No, go ahead.
Oh, some of it might look good, may have been done without a permit or by somebody that wasn't in the trades. Sometimes it's hard to tell, but the obvious stuff, just write it up. Take a picture, write it up. Is that 7:59, Jim?
Yeah, we're running a little bit late. We've got about 10, 12 more slides to go. So we'd like you to hang in there. If you've stayed, If you need to go, it's 8 o'clock. That's fine. We got probably about 5 to 6 more minutes to go. But if you need to leave, you can. You'll still get your certificate, so no worries on that.
All right, so we kind of talked about moisture in these older homes, and it's exterior water management, just like any home. Foundation moisture more prevalent in a home with stone and brick, and that gets tied in with the exterior water management, right? Because we do want to keep the water away from the house, and if we keep the water away from the house, we're going to minimize any dampness that comes through the foundation. Not all foundations are leak. I've seen some really good stone foundations that are dry as a bone, but I usually know from the outside what I may be looking for when I get inside. So, interior condensation, we have a whole webinar on that, where it all comes from. When these loose houses like this, they let moisture in, but sometimes they don't let it out. So there are a bunch of areas that moisture can come in. If you see anything that you're uncomfortable with, little spots of mold growing, there's an issue with the moisture in a house. And then bathroom and kitchen moisture, any home. But usually these older homes are not equipped as well to get rid of this moisture. So big things to look for on the inside of the house. I don't know if we need to really identify wood species, but old growth wood, you're going to know immediately if somebody made a repair with new lumber. It's just going to be like night and day. But the white pine, chestnut, oak, and hemlock from back then were definitely more resilient and rot resistant and dense. And a lot of these older homes, you'll see termites, but they don't do a lot of damage because the wood is just not the type of wood they like to consume. And then cedar and cypress and hard pine are naturally resistant to decay, but they're going to be hard to identify. So you're just looking for rot, and we don't need to know what kind of wood it is, really. If there's rot there and it's significant, it needs to be replaced. Historic mortar was a little different. So it was, based on modern Portland cement-based products. So it would happen to deteriorate. So when you go in a stone foundation and you see at the base of the foundation all that mortar that just disintegrated, that's because of the quality of mortar that they used to use there. Or if you brush the foundation down, more of it will come down. I usually tell people to brush them down. I don't think it's really compromised the foundation unless I see something that I think is an issue, but I would clean all that up and keep track of it. If it continues, then you may want to have somebody come in and repoint. So this, again, applies to any house. When you're going through the house, it doesn't hurt to pay attention to see if you think any repairs were made. A lot of times pieces of sheetrock are taken out and they're not really well taped when they go back in. So if you see any scarring in plaster or drywall, paint color variations, differential flooring finishes, that all suggests modifications in the house, whether it was remodel or repair. I'm more concerned about removed walls, things of that nature that were not properly resupported. And that would also tie into altered floor plans. That's any house for me, anyways. Do you see different foundations? A lot of times you'll see stone and then you'll see it stop and trying to tie in a poured concrete under an addition. Well, that's an addition. And you'll see a lot of that in the attics and basements. That's where you're going to want to look at for it. And then roof line changes. It's very, very difficult to maintain a roof line when you're putting an addition on. That's why, in my opinion, you should drop it down with a fascia board so you don't have that hump or the sag. But that's what you want to look at. If you see more than normal deflection or changes in the roof line, it could be an addition. But I think you're going to realize that after a while anyways. Historic plaster, it is what it is. You know, it's going to age, it's going to fail, it's going to be repaired if they want to keep the plaster with modern plaster. Most of it comes from just age or water damage, so you're going to be looking for water stains, and then document the extent of the problem. Is it a quarter size water stain? Is it a 2 by 2 foot loose piece of plaster, or is it much more significant? Because then obviously it's more expensive and more difficult to repair. I'm going to skip this because we've already talked about the types of insects that um, will attack any house, and they all do damage. So they all need to be looked for and called out if you see any evidence: termite tubes, powder post, beetle holes, carpenter ant frass, and whole house borers. Bring in a pest control guy. Environmental hazards are the same, but could be in a greater concentration. Lead-based paint was there was more lead in the paint back in the houses back then than there was in 1978. So a greater concern if there's old paint still in the house. More potential for asbestos-containing materials in an older house. Mold in the foundations. There's people who dispute that, but mold, anything will grow on anything. So if you see growth in the basement, you want to recommend somebody come in and test, in my opinion. And then radon concentrations. Radon is much more difficult to reduce in an older home that doesn't have gravel underneath the if there's a slab or in a dirt floor basement, can become a costly issue. So same environmental concerns, but maybe at a higher level and a higher cost to correct. Asbestos video, Jim? Yes.
Yeah.
Asbestos,
Tape.
asbestos tape on the ductwork.
There we go. Next.
Thank you. So just briefly, I don't think it's a bad idea to test and document for lead paint in an older home unless you think it was totally renovated. That doesn't mean anything. There could be lead paint dust if they didn't do things properly. But we'll tie that into the previous environmental issues. And, you know, some people are uncomfortable identifying, so we're always saying appears to be, maybe, could be. I think it is. But pipe and boiler insulation will likely contain asbestos in older homes. Floor tile and mastic 9x9 or 12x12. And if you see that the tiles were replaced, but the mastic is still on the floor, there still may be asbestos in that. Textured plaster may contain asbestos before 1980. Siding and shingles, and the dreaded vermiculite insulation.
Next one.
Fire safety in historic homes. We want to make sure smoke and CO detectors are in place and follow what our standards tell us to do regarding that. You can make recommendations that they have fire extinguishers in the home. We want to do the same thing as we do for any other house and make sure that there's proper emergency egress, especially in the bedrooms. And then electrical fire hazards. We talked about the knob and tube and poor wiring techniques. And that's exactly why those things should be called out. And your report should reflect that they could be electrical hazards. Accessibility and universal design issues. Steps at exterior entries without ramp access. Narrow doorways, often 30 inches or less. Steep stairs, definitely the runs are shorter. Bathrooms too small for wheelchair turning radius. Kitchen counters and appliances at fixed heights. Electrical outlets and switches at inconvenient heights. Bathtubs without grab bars or level entry showers. Upper story bedrooms with no main floor bedroom option. I don't know if those are all barriers, but those are some things that I would probably discuss in the inspection. Energy efficiency, I'm going to say, forget it. unless the house has been renovated and some insulation's been added or you've upgraded windows. There's definitely going to be 50% higher heating costs. Zero, again, unless something was installed, and heat loss is big time through the older windows. And don't forget, even though you have a thermal pane window, if your exterior walls are not insulated, that window's not going to be as efficient as it could be with an insulated wall. So it doesn't help a whole lot. Insurance and financing challenges. Well, today insurance is becoming ridiculous for everything, but they are making things a little more difficult for older homes. And the knob and tube and outdated heating systems, older roofing can apply to any home at this point regarding insurance and insurance. I did a home inspection for a guy who worked for Progressive, and he said that within 15 years, over 50% of the homes in the United States will not be insurable without underwriting, I think he said, because that's just where we're going. So questions and CEU completion.
We're good.
Thank you for attending. Thanks for sticking around if you stuck around. And we hope to see you at the next one.
Yeah. So we got a lot of exciting things coming up. I'll get certificates out to you in the morning. Yeah. For our New Jersey inspectors, we just put up on the website, we are going to be offering New Jersey ethics in a 1 hour. And then 2 weeks after that, I think we have the New Jersey law and standard of practice. That's 3 hours over 2 days. You can sign up for there. That's it. Thank you for coming tonight.
Thanks again. I appreciate it.
All right, see you guys.